Welcome to Module 5, Lists. This week we're going to learn how to make lists in Python and how to use them and modify them. Many programming languages have the concept of an array. An array you can think of as being a collection of a certain data type. In an array, all of the entries have to be the same. However, in lists in Python, we can have different data types in the same list. So we can have both text and numbers in the same list together. Lists are a nice way of storing different pieces of information in the same package so they can be referenced together and kept neat. In a single list, you could have hundreds of items. If you didn't have the concept of lists, then that would be hundreds of different variables to keep track of, and hundreds of different variables that you, the programmer, would have to write up front. So lists are nice for keeping lots of different information together in one package. To make a list in Python, we use square brackets. So let's say we wanted to make a list called my list. And let's include 4 items in that list. We'll include the word spam, and then the number, or the word eggs, then the number 2, and the number 5. So we have a combination of text and numbers in our list already. So this is now all together in one package, as you can see by the brackets. So I can print out my list, and it will print out that entire package of information. However, if I wanted to access a single value within that list, I can do that too and not have to pull out all of the information together at once. So let's say I wanted the first value. To print out the first value, you put square brackets on the end of your variable name, and then for the first one you use the number 0. Lists in Python are what we call zero indexed. So just like strings, where we got the first value of the string using index 0, we get the first item in the list using index 0. So if I run this, then I will just get spam. And in fact, you can get the second value using number 1, and the third value using number 2, and the fourth value using number 3. So let's see what happens if I try to get a number that doesn't exist. So I'm going to try to get the 5th value from this list using the number 4. In that case, I get an index out of range error. That means that you've tried to access an entry in a list that doesn't exist. So there is not a 5th item in my list, so if I try to access entry number 4, then I'm going to get this error. This is nice. Some languages like C don't have a way to do index out of range errors, so it can get very tricky to debug if you run past the end of an array. But in Python you do, so that's very helpful. You can access the end of the list by using the number -1. So if I do my list -1, it'll return 5. If I do my list -2, it'll return 2. 3, it'll return eggs, and -4, it will return spam. Notice that if I do -5, then I'm going to get that index out of range error again. We can also get pieces of a list by using slicing. So let's say that I wanted to get the first 2 values of the list. Then I would do 0, colon, and then in this case, if I want the second one, then I do 2. So you always do the index right after the one that you want to stop on. So it's just like in the range function where we always put the last bound to the number after we want to stop at. In this case, it's not inclusive. So this slice will do entry 0 and entry 1, but not entry 2. So if I run it, then I get a smaller list, spam and eggs. So you can take out pieces of a list quite easily. So let's say I wanted to do eggs and 2 as one list. I would start at 1, and I would want to go to 2, so I have to put 3 as the end. And then we can do that as well. Let's say that I wanted to get a sublist from one entry to the end without knowing what index the end of my list was. Let's say I want the sublist eggs, 2, and 5. then I can do 1, because that's where eggs is, then colon, and then leave the last blank. So that will return eggs 2 and 5. It also works the other way around. If I want to get everything from the start of the list to an entry, I can do, if I want to go spam eggs and 2, I would do colon, and then 2 is in the second entry, so I would do colon 3. Spam eggs and 2. So that's called list slicing, and it can be very helpful. We're not going to do a lot with list slicing in our practice problems this week, but I wanted to give you some exposure to it so that it looks familiar when we use it a lot more later. But for now, the most important part is knowing how to access single entries. So knowing if you want eggs, then you have to get the first, or get index number 1 to return that value. We can also have lists as entries to lists. So let's say instead of our last value being 5, we want our last value to be another list. So let's say 1, 2, 3, 4. So now notice that you can split lists across lines. If you print out my list, then it's going to give you spam eggs 2 and then the list 1, 2, 3, 4. So this is nice to be able to split lists across lines sometimes because it allows you to make your program look neater, and sometimes you'll have a list that's really long, it'll go trailing off to the side, and then it's nicer to be able to wrap it around and keep it neat than have it go off the page. So you can put list entries on different lines as long as the comma ends the line and you have both brackets. Let's say that I want to access the second entry, so this 2, inside this list. So this list is entry 3 in my parent list. So if I print 3, then I'm going to get the whole list. It's returning that list at that entry. And now, if I want to access entry 2 of that, I can use a second pair of brackets and then put in 1. So now it will return just 2. So this is how you access entries in a nested list. You do the brackets for the parent list to find where that nested list is, and then second you do the brackets for the inside list. And you can have as many list nesteds as you wanted. So if I had yet another list inside this list, then I would have 3 sets of brackets to access a single entry within it. So what this portion is doing here, it's grabbing the list at position 3. So if I wanted to, I could even put these in parentheses to really emphasize that first I'm grabbing that list. And then from that list, I'm getting index number 1. So if I run that, I still get 2. Sometimes it's useful to know what the length of your list is. So in this case, we can count them. We have 1, 2, 3, and then all of this counts as 1 entry because it's 1 item. So we have 4 entries in here. But sometimes it's not feasible to count, or you've generated a list within your program, so it's easier to use the len function. So if I do len for length, parentheses, my list, and then run that, it will print out 4, which is the size of my list. If I add another entry to this, and run it, then I will have 5 entries in my list. So the length function is very useful. So sometimes you'll be creating a list like this up front, and sometimes you'll be generating it within your program. So let's create a simple program that makes a list of all even numbers, and we're going to do this using a for loop. So I'm just going to get rid of this right here, and I'm just going to add a variable number of evens equals 12. So in programming, sometimes you'll have user input, sometimes you'll be reading configurations from a file, but when you're making little programs like this, it's fine for you to set a variable up top for you just to play with. So if I want, when I finish writing my program, if I want to generate a list with 20 evens, all I would have to do is change this number here. And that is a perfectly fine way of working with your program before you put in any user input or anything like that, and just manipulating the variable yourself to see what the output is. So I want a list with 12 evens. So I'm going to start off with an empty list. So to make an empty list, we're going to do evens list, and you can do empty brackets like this. So this creates an empty list. If I were to print length of evens list, I get 0 because there's nothing in it. It's just empty. So now I want to construct the list with the evens. So I'm going to use a for loop and that range function. So for number in range, and we're going to go, we'll include 0. So if I want 12 evens, then I actually need 24 numbers because evens are only half of the numbers. So I'll do 2 times number of evens. So if I have 12 evens, then this whole number here will be range 24. So it will count up to 23, but it will include 0 as our first even. So we'll get 12 evens. And then we can do this two ways. We can either write a check inside the for loop to see if a number's even, and if that's the case, add it to the list, or we can have our for loop count only evens. To do that, we need to add in our start, and we need to add in our step. So in this case, we're starting at 0. We have 2 times the number of evens as our stopping point, so 24, and then our step size of 2. So this will print out only even. So if I did print number, just to test it out, and ran that, we would get all of the even numbers below 24. So that goes 0 through 22. And if we count them, then we have the required 12 here. But just printing out the numbers is not creating a list. We actually need to store it to our evens list. So to do that, we're going to use what's called the append function. So you do evens list dot append, open parentheses, and then put in what you want to append to the list. So number. And then we'll print evens list after that to make sure that we did this correctly. So if I run it, I get the list of all my even numbers. Now I just want to point out something really quick. If you weren't getting evens list to print out something, print out correctly, let's say that you had a typo here and you had put number of evens instead of evens list, and then I ran it, so it's going to be 12 every time. It can be hard sometimes just looking at the final output to really figure out what's going on. So it is fine to put a print function inside your loop to look at what's going on in there. So I haven't noticed perhaps that I put number of evens, so I want to make sure that my number is counting up correctly. So if I ran this, I would see that every loop my number is printing out correctly, so that's good, but then I'm getting suddenly this list of 12s at the end. So I know that I'm not actually appending number, I had made a mistake, so I just need to delete that, and then it works fine. So adding print statements to your program is completely fine, and it's a good way to see what's going on at intermediate steps. So you aren't just limited to looking at the initial values and the end values, you can look at intermediate values as well. So let's see what happens if I print out evens list every time. So I do print evens list, and you'll see the list being built. So we start off, we append 0. In the next round, we append 2, so we have 0, 2. And then the next round after that, we append 4, so we have 0, 2, 4, and so on and so forth. With every iteration of this for loop, we add another number to evens list. So we've constructed a list of 12 evens. And if I wanted to change this to 10 evens, all I'd have to change is that variable up top and rerun it. And I would get the first 10 evens, the first under 20. Let's say that we want to loop through the list and print out each value multiplied again by 2. So we want every single value in this list multiplied by 2 and printed out. We can do that using another for loop. So this for loop, we created the even list, and then in this next for loop, we're going to print out each entry times 2. So we can do for item in evens list. And I'll just show you what that looks like if we print it out without manipulating it. So we did for item in evens list. So if I run this, then it prints out every entry in my evens list. So what this is doing is this for loop is visiting every single item in evens list, and then it's accessing it, was temporarily saving it to item, and then it's printing that out. So if I wanted to print out every entry in evens list times 2, then I would do item times 2. And then I would print out, then that would be every single entry in my evens list multiplied by 2. I could also add 2, to each one, and then it would just shift up my evens list by 1. Let's say that I also wanted to print out the index of each item. So we can use that using something called enumerate. So if I do enumerate evens list, then instead of item, instead of just getting the entry of that list, I also get the index. So you do index, comma, item in enumerate evens list. So this is saving the entry to item, and it's saving the position in the list to index. So if I wanted to print out the index and then followed by the even, I would do index, comma, item. And if I run that, see at the 0 position, it's entry 0. First position, it's entry 2. 2 is 4, 3 is 6, 4 is 8, and so on and so forth. So getting both the index and the item is very helpful sometimes. Let's say that I wanted to not just access but modify let's say that I wanted to not just access but modify my list as I loop through it. So I want to take each entry, and instead of just printing out it multiplied by 2, I want to multiply it by 2 and then save it back to the same position. So I can do that. I'm going to print out index and item. So you can see what it looks like before modification, and then print. I'm going to start by printing out my list before modification, evens list, and then I'm going to modify the current value. So I do evens list, square brackets, index is equal to item, because I want to modify, I want to use the value that was at that position, not the position, to calculate my new value, and then times 2. Actually, let's do squared. So to do the power of 2, I do item star star 2. So it's going to take every number and square it. And then I'm going to print evens list again. And I'll just make 5 evens in this case, so we have a small example. So just to make this easier to look at, I'm going to add before squaring, and then after squaring, and then run that. So we start off with our very first round. Before squaring, we have 0, 2, 4, 6, 8, and after we have the same thing. That's because this is accessing the first position, which is 0. And 0 squared is still 0, so we don't actually change anything here. So the second round, we have before squaring, we have 0, 2, 4, 6, 8, and then after we've squared this number 2, we've squared the second value in our list. So we have 0, 4, 4, 6, 8. And then again, we have before squaring is the same as at the last step because we haven't modified it again yet. And then we square 4. And then on the time after that, we square 6, and on the time after that, we square 8. So we end up with our final list. Print final list evens list. We get 0, 4, 16, 36, 64, the squares of the first 5 even numbers. Instead of printing out, we saved the square of the number back to evens list. So you can see the progression of the list looping through, or the progression of the loop going through this list.